Hi there and welcome back to Triplicate, and we are going to move on with looking into our two faulty water pumps and seeing if we can fix them. And I was in this video going to move straight on to taking the water pumps apart, tearing them down as we say on YouTube, but in the meantime I have bought a proper accumulator rather than a reel of old hose pipe. So I thought I'd take this one, which sort of works, the other one was all over the place, and see how our test system works now. So we have our bucket of water, which hasn't got any water in yet, our big reel of wire to connect it up to the car, costs, as I said, it's the only source of 12 volts 10 amps I have. So I will connect it up, fill the water up, and we'll fire it up and see what happens now. Excuse the washing machine in the background. If you want to see what that looks like, go to the whiter video I did maybe a couple of months ago now. Okay, so first up I have here a watering can full of water, so we will apply that bucket. That looks good enough. And I have a multimeter. So I can just check that the voltage across it is adequate, because it's quite a long run of wire between here and the car, and then it's coming out of the lighter socket. So first up we will turn the tap on and fire her up. Okay, there's water coming out of there, and our voltage is okay, so that's not good. We've only got 10 volts there, so that might not be, I mean, these things are supposed to work to 10 volts, but it's not brilliant. So now let's shut the tap. And it should be going up to about 1.7 there. And that's down to 8.8. And it's just getting... Okay. So what I might do is a very environmentally friendly thing and just start the car engine. So there's a bit more volts on the battery, and hence a few more volts here. Okay, you can hopefully hear the car engine puttering away to itself in the background. So what happens if I connect that up now? 10 volts, 10.5 volts. And it's not quite getting there. for interest. Yeah, 14 volts with no power being drawn out of that circuit. Alright, I need to think. Alright, not at all flaky, honest. So we have here the battery out of my 14.4 volt Clark, which is machine master cheapo drill, and it's on its charger, which is plugged in and going. And this is, did you see that? This is the plug for the super battery charger, the triplicate super battery tester charger, and there's a series of videos on that if you're interested in testing and charging and the performance of batteries. And here we have two little, they're just blade connectors pushed in there, so two little wires going out to here, and can you see the meter? Probably not. So that's 15 volts open circuit, but it won't be 15 volts once it starts going, believe you me. And I do remember at one point this battery had smoke coming out of it, so it's a bit suspect. Be a lot suspect now. So should we I opened up the valve, the accumulator emptied very quickly all over me. Oh dear. I'm wet now, and there's wet all over here, and electrics, and well, you know. So this is with the tap open, so this should pump very nicely, and the voltage across the pump is prober in there. Okay, nearly 14 volts. We'd expect that if we were going along, the engine was running, we'd expect that sort of voltage across the pump, and if you're getting a nice amount of flow out of there. You see that? It's my hand in the way, probably. So if I now shut the tap, the pressure comes up smartly and it turns off. So, is that pump not faulty? Oh dear, dear, dear. Well, I have to say, I don't think it's performing as well as it should. Now, I did take it off the boat and replace it with the other one, and while it wouldn't get up to pressure with this one on, it would with the new one on. And since the batteries are at one end of the boat and the water pumps at the other, some like 12 metres apart, I want to measure what voltage. There we go. It's just dribbling out very slightly, it's not completely off. What voltage actually arrives at the water pump when it's under load on the boat. Maybe I should measure that next week when I'm down on the boat. Okay, so let's try the other one. Again, quickly, since we got it set up and before the whole place gets drenched in water, I opened the tap on the full accumulator again and got another load of water all over me. Just as well it's only water. So, okay, the tap's open. You probably can't see that because this pipe's in the way, and yet no, and the meter's in the way. However, there we go. So, where's the power? Let us okay, should we try it again connected the correct way around? Where is the wire? And is that in short? So, connector up. That's the outlet. having before, it wasn't priming itself. Is this a good idea? No. Something's coming out of it. Okay, shall we now see what happens if I... Doesn't sound good, and it's just getting up to 1 bar in a bit. And this should be about the same 1.7 bar turn off. She's a duffer. Let the pressure out. Well, I think we might tear into this one because I never expected it to run again anyway, so nothing really to lose. Alright, first victim. What we'll do first is pull these wires off, I think. No, maybe we won't. Oh, that one's come off. Well, we'll pull that one off because that's between the bits we're taking apart. And we will get these big screws out of the end here, and that should take the pump off the motor. So let's do it. Nope, yeah, they're not exactly super tight. Maybe I did just chuck it back together. Hand tight so as not to lose any screws or anything. And it explains why it didn't work. Yeah, and it's depositing water on the desk. That's a water pump. I don't know. Oh, hang on, what's going on here? Coming apart there. Right. Okay, so the 3 ones that go down through it hold the pump assembly onto the motor, and the 3 outside ones with the nuts on hold the pump together. And let's have a look. This is the motor. It's got 2 suspiciously rusty looking screws. Oh, that's just it's an offset thing centered in there, and there's an offset there, and that's a little bearing, and it drives those round like that. So effectively these little pistons are moving backwards and forwards, and presumably in here we have some kind of check valves. Okay, so let's get rid of these long screws. That one doesn't want to come out because of the pressure switch. So I think I need a pick or something. These just lift out of these, and are they... Oh, there's a little tab there. Well, let's take them out. They are all located that way. And what does this? Yeah, that lifts out. Oh, there's a sticky down bit there, which I guess goes into, yeah, so that locates those. Okay, so this is the outlet. Alright, so that has a check valve somewhere in here, and this is the inlet. Oh, and that's the overexcitable dog. That doesn't appear to have a check valve. Maybe it should have a check valve. Okay. Well, let's dig some further. I don't know whether this screwdriver is going to do these. Is the screen going to come out? Not easily. I'm going to leave it alone for now. Instead, should we have a look at... Yes. In here, which is the pressure switch, and hopefully access to check valves and things. They must somehow make the check valve. You know, put whatever it is in. It must be from here. Right. So that is just a micro switch. So when the pressure comes up, that rocks over and the switch floor comes back. Does this come out? It's just a pushy thing. Right, does this come out? I think it ought to. Ah, come on. Right, that is just a stick thing, and that is the actual membrane. Now, this must be connected to that, and there's no way there's any screws from the inside, so screws, yeah, I can see. Okay, it just lifts off, and these two screws hold the cover on and hold this onto the main body of the pump. Right, so we have a little spring, and we have a thingy, a little rubber thing. Okay, so I figured it out. The inlet comes in here to this big chamber, and the output goes into this chamber where these three lobes here, which are all connected together, under there and out of the outlet, and thus goes in here. And you can see these red rubber diaphragms cover these little holes which come from the inlet. So when the piston moves up, this is pulled up and water is pulled into this little chamber underneath the piston. Then when the piston goes down again, the water is forced down through there, and if we look on the underside of this, oh, it's sitting in there. I'll just retrieve it and stuff it in here. Yes, the water is pushed down through that semicircular and pushes these diaphragms down, and then the water goes out past through that hole down into there and out through there, which goes into the outlet there. Gotcha! However, I did discover when I took this off, I might need to put this closer to the camera. These, you can see here, return it over, these guys are not good. They have torn, I think all three of them to some extent. There, so I think our pump did fail. These diaphragm tore. So the question is, can we get a replacement? Okay, so here we have a diaphragm kit for the Aqua 8. Well, it looks the same. It looks the same. Do I want to spend £15 plus no doubt postage in the hope that it'll fit? I might have a further dig round on the internet and some forums, see if anybody's actually tried to put one of these in my type of pump, or am I just gonna call the pump dead? Don't know for now. Okay, so in the end I ordered a diaphragm kit for the Aqua 8, which is the modern version of this. Looks the same, hope it'll fit, hope it comes on like a clear plastic bag so I can compare it to the one that's in, and if it's different, send it back. And of course I got an email saying it was out of stock, so goodness knows when it will arrive. So away with this one, and in victim number 2, the jab scone. So I reckon, looking at this, there are a bunch of screws around here which I reckon hold the two halves of the pump together, and that splits there maybe. And there are 2 screws in the back here which I guess hold the motors and the pump together. So I am first up going to try and get them out and see where that takes us. Ugh, cheapo self-tappers into the plastic rather than threaded inserts. However, magnetic trays, magneted to all my tools. So is this going to just drop apart? How do I, right, I think I have to get this off, this cover off, and hopefully disconnect that wire somehow. Yes. There we go. So now it should just slide apart. Now, alright, that wasn't what I was expecting to happen. Okay. Let's start on these round here. And they're not all the same length. Have I been paying attention to which ones go where? Nope. So that I'm guessing that's the longer one and this will be a shorter one. Because there's less place. Oh, maybe these longer ones are the ones that hold the pump together. Pump onto the motor. So that is a shorter one. And this, I'm guessing, will be a longer one, so it's all going to flop apart. I don't get this screw out yet, that's a longer one. Mystery solved. Right. Yep. Oh. Right, cloth. Throwing water everywhere. So again, this is the inlet into this big area here, and that's the outlet which comes out of that, and that is the pressure switch. And I say, I do not know what this little thing is. Is it an overpressure safety thing? Maybe it is. I'm not going to do it any good poking it with a sharp point. So, how does this lot come out of here? Does it just lever out? Oh, I think it might do. It seems to be held in by vacuum. I can hear air hissing around something in here. Oh, hang on, that comes off. Ah! Yeah. It's a bit grubby. Is that just it? Is it just a bit grubby? It's a lot grubby. Sludge. That is why we don't drink the water out of the tank. Okay, so that comes off like that. Aha! And that is just screwed onto the motor. The motor seems to spin relatively freely. Okay. So I reckon these valves here open in this way. So when the pistons are here, the piston comes up and this opens like that and lets the water into this chamber here, and that goes down into the middle chamber, which is the output, via this valve here. Don't know how flexible these are supposed to be, but that one does feel a little hard. Nothing's broken, and as I said, it's all they do seem a little hard. I don't know how pliable they're supposed to be, but they do feel quite hard. So perhaps this wants diaphragms as well. And a damn good clean up. Yuck, yuck, yuck. Scummy, scummy, scummy. Go on then, while we're here. Stove the pressure switch off. See what's going on in there. Let's get pushing yet. And there's another rather scummy membrane, and it appears to be sealed unit, so we are not going to mess with it. Basically, it was working, I think, and if it isn't, we've got to replace it with the unit. Whoops. Alright, here we are in the Jabsco shop. 1827 plus VAT plus postage, £25 for a new valve kit, the triangular bit. And there doesn't appear to be anything wrong apart from the fact it's crudded up, and those membrane diaphragms in that valve unit do seem a bit stiff. So we shall chance our arm again, grab a new valve kit they call it, and this one does fit our pump, we know. So there we go, add to basket, and we're off. Right, there we go, we're waiting on parts to try and resurrect both of these, and I will clean this out off camera. God, it's disgusting. So I'm going to end this video here because goodness knows when we'll have the parts. I'll throw this one back together quickly so I don't lose anything, and we will reconvene on video number 3 on these water pumps. We'll put them back together and test them and hope at least one of them is reborn, refreshed, renewed. So until then, it is goodbye from Triplicates. Goodbye.